Let's talk about Lua policy helpers. When we developed KumoMTA, one of our goals was to make it as flexible as possible, which is why we implemented the concept of config as code using Lua. So while KumoMTA itself, all the heavy lifting is written in Rust for safety and performance, we use Lua for all of the configuration so that anything is tunable and adjustable and can be integrated into your larger environment. For example, you're able to do things like look up a database to find out how to do DKIM signing, which selector, which key to use. You could configure your IPs by reaching out to a directory and finding out which IPs are pre-configured and then using Lua code to implement that in real time as part of your configuration. That does provide an extreme amount of flexibility, but we also understood that in turn it was going to come with the cost of complexity. And a lot of the users that are migrating over to KumoMTA are accustomed to a more straightforward configuration approach, and at least in the initial migration, they'll be looking to continue to use that approach. So to that end, we've introduced what we call the policy helpers. And what the policy helpers do is they simplify back down how configuration is done for common use cases by implementing a text file as the data source for the queries that are done to configure the server in those areas. So looking at a quick example on the screen here, one of the things you'll notice is okay, how do we do DKIM signing normally? And what you'll see here is that there's an event that is caught. There's a hook that is caught that is handling SMTP server message received. So every time a message comes in over SMTP, this code is going to be executed. And there, one example of how to perform dynamic DKIM signing is to look at where it says, all right, we're going to create a signer that is going to do a SHA-256 signature. It's going to set the domain value for the signature based on the from header of the individual message. The selector is going to be default. The headers are going to be from, to, and subject that are signed. The key is going to be at the default path, this PEM file. Now, after that, that sets up the signer, and then at the end of the code for the SMTP message received, you're going to see that it does a message DKIM sign and uses that particular signer. And what that does is it says for every message that comes in, we're going to use this fixed value. Now from there, you can modify that Lua code, obviously. You could do things like, say, take that domain information, do a data source query against SQLite to get back what selector to use, what headers, the key value that's supposed to be used for that particular signature, and then you could perform that DKIM sign. So rather than having us write a module that talks to SQLite, you're simply able to use Lua config as code to do the lookup any way you like and retrieve that. But again, that comes with complexity. So we see here, right? Do a DB execute, select the data from keys where domain and selector equals, and then take that, do a return, and do the signature from that. Kind of complicated. It's very flexible, very powerful, but if you're coming from another MTA solution that was simply expecting there to be a configuration file on the disk and that there would be directories, for example, set up under a DKIM directory where one directory is named after the domain to be signed for, and then the file itself is named after the selector, then this is, by comparison, quite a bit more complicated. And we wanted to be able to simplify it for those who are coming from that environment and either wanted to initially migrate under the same model or just completely stay to that approach because it works for them. And so we introduced the helpers. And what the helpers are is they are Lua scripts that are included in the distribution of KumoMTA. And those scripts are free, again, for you to see, for you to look at, for you to modify. But by default, we've built them around the concept of reading either a TOML or a JSON file for the information needed, and then essentially implementing this code on your behalf inside that script. One of the advantages of a helper is it makes it so you can use just plain text configuration files, either TOML or JSON, which allows you to either do hand editing with TOML or very easily write out a fresh file in JSON that you can then have your automated systems just write to the file rather than having to edit a text file. So for example, in a lot of other implementations, I've seen people have to create scripts that query a data source that the company already has. They then take that query result and use it to build out an include file that will be loaded by the MTA, and then the MTA will be told to do a reload of configuration to get that new information. Obviously, you can query directly to that data source, but if you want to keep that idiom, rather than having to, use a key value pair config file like a lot of these are set up with option equals value, your standard kind of INI file format, TOML and JSON make it a lot easier to automatically recreate and update those files as well. But the difference here is you never call the reload, because you'll notice this is always done based on an event of a message being received. You can use Memoize to cache that information, for example, but the server never needs to restart for these changes because it just goes back and reads that file again. So a helper, by comparison, instead of all of this code up here in the event, we have what you'll see down here, which is we do a DKIM sign is policy extras DKIM sign. That DKIM signer is just DKIM sign setup, and it tells it where to find the file. You can list multiple files here, so you can have a JSON and a TOML or just a JSON. They overwrite each other in order that they were written down on disk, so you can then have two different places that you edit. Maybe not so much for DKIM necessarily, but for things like traffic shaping, you might have your default rules in TOML, and then the dynamic ones that you're making on the fly you might do in JSON. It's up to you at that point. But what you see here is instead of all of the other code, it's simply DKIM signer and message, okay? Because that DKIM signer is being built by that policy extra script. So with that, someone can then configure DKIM signing, very straightforward. In this case, for example, here's a TOML file. It just says if the domain is example.com, the selector will be DKIM 1024. These are the headers I want signed based on that domain. This is the algorithm I want to use. And the file name, in this case, if you want to override it, you put in where that key is going to be found. If you want to stick to the default, we've done that as most people would expect. Opt KumoMTA etcdkim, and then a directory named after the domain, and a file named selector.key. So this makes it very straightforward to continue the approach that's been used previously during migration of simply manipulating that directory of DKIM directories and selectors to add the new selectors when needed. You can also, with these TOML files, set up a global default. For brevity, we didn't include it in this example, but it allows you then to also customize what the default settings are and just override them for that particular domain. So if you look at the DKIM signing documentation page, under configuration in the user guide, it says configure DKIM signing. You'll notice that for us, again, here's an example of what that looks like if you manually do it through Lua, but using the policy helper, here's what the full configuration file looks like. So we can use a vault location in HashiCorp Vault for where we want to store our DKIM signing keys. Highly recommended, much more secure. We can configure that we want to do double DKIM signing. Maybe as the sending entity, we want to have a signature specifically that's added to all messages because they're passing through our environment. You have the ability to say, what's the default selector? What's the default header config? This then takes place for anything where the key is located in the proper location on disk. But we can still go in and say, okay, for this particular domain, we want to make some overrides. We want some changes in policy. We want some changes in what headers and algorithm are used. Okay. From there, we also have the ability to say, hey, that custom signature we talked about, here's where we configure it. This is what the domain is of that custom signature block, and whether to do it always or maybe just if there's not an actual domain for that particular send. So if the customer of yours, your tenant, doesn't have that signature information in place, then we're just going to do the ESP signature, or we're always going to double sign. So we'll do it whether they have their own signature or not. Very easy to configure, very easy to manipulate. And again, all of this information can also be written in JSON as well as in TOML, just depending on your needs. Some other examples for this, traffic shaping. So if the traffic shaping automation, rather than having to manually put all the traffic shaping rules in place and implement them based on essentially event triggers, where we have get egress path config, which is saying, hey, I need to do a send out. What do you want the settings to be? You can, again, edit a TOML file, right? We have one by default that we provide to our users. We're constantly trying to grow and improve it. We're happy to have feedback on your part to say, hey, this is a rule I think should be part of the default. But then you can also override that with either your own TOML or your own JSON file that is either replacing or appending what's in our configuration file for you. And that, again, very simple. You have what is my default, what is a domain, how do I want to configure the traffic shaping rules when sending out to that domain or just in general by default. You update that file and you're able then to use it for configuration using the helper rather than implementing those event hooks yourself. Similar thing happens with our queue module. So rather than having to manage tenants, campaigns, scheduling, all of that, and which egress pool is used by which tenant, you can use the helper. You set up the queue module. This is where it's located. The queue helper then is set up. Here's where my configuration file is going to be. And in that file, you're going to find things like, I want to use a specific header name to indicate any kind of scheduling that needs to occur to a message. If you want it to start and stop at a specific time of when it's alive, when it's actively sending, when it's not, maybe you have time of day restrictions, or you just want to delay the start of a campaign, you do that with the schedule header. The tenant header allows you to say, hey, I have tenants in my system. This is how I want to identify them. In our case, we're saying you're going to put the name of that tenant in a header. You're dictating that the name of that header in this case could be X tenant. And same thing with campaigns. Because we queue on a campaign granularity, you can give us a campaign identifier. It doesn't have to be under X campaign. You can name the header whatever you like, as long as there's a string in there that represents your campaign. And we're going to use that to make assignment. And then if there's no header, or if it doesn't match up, you can say, what is our default tenant going to be called? And then configure the default tenant. And then for each of those tenants, you're able to go in and say, okay, for this tenant, I want to use this egress pool. So now you're configuring your IPs, you're putting them in pools, you're assigning those pools, you're assigning tenants to those pools, I should say. So this doesn't have to be dedicated to that single tenant. This could be a shared pool if it's a shared IP customer. If it's a dedicated IP customer tenant, then you're going to create a pool specifically for them, which is in a separate helper that I'll show you in a second. With that, you're able to say, okay, so this is my tenant, this is the pool, this is how long those messages should stay alive. And if you want to, you can also say that in order to relay for this tenant, they have to be an authenticated user using SMTP auth on connection, and that username has to be a certain username. If you're essentially exposing your server to outside injection by your customers, you're going to require authentication, and you're going to be able to require that those customers are only able to send through a specific tenant. And the reason you want to do that is so that they can't spoof each other. In a lot of implementations I've seen over the years at ESPs and other large senders that do multi-tenancy, there's not always a validation of whether the person injecting mail is attaching to the tenant or binding or virtual MTA that customer has been allocated. And so if someone has knowledge of your environment to the point that they know that they have an account and they know that their identifier is X, but they know that another tenant's identifier is Y, they can pass that Y identifier sometimes and spoof another tenant of your server because the server isn't validating that they actually are attaching to the tenant that is dedicated to them. They just look for a valid tenant name, for example. Here, you can go a step further and require that authentication to be for that specific user account. And then you have defaults for queues. So by default, we're going to say the max age is 22 hours. We're going to say that the retry interval is whatever it is. But from there, we can not only adjust for tenants, we can also adjust for destination domains. So we could say, if that queue is to Gmail, we don't want to have 24 hours. We want 22 hours. We want to retry after 17 minutes. And then you can work your way through and say for this tenant when they're sending to Gmail, those kind of things, as well as by campaign. Keep in mind that the queue helper is specifically for rules around how long messages are in the queue, which means that when they're in their standby queue. So we don't put traffic shaping rules here for how many connections to open, how fast to send messages, any of that. This is for messages that are waiting. And that's why we have age information in here, retry information in here. These are the kind of things that are set based on that scheduled queue, because the scheduled queue is when we are not connected to a remote host. And that's where age and retries and those kind of things come into effect. So this is how you would use the queue helper to set up your tenants, campaigns, even your scheduling, and then how those queues are working as far as what they get assigned to for pools. Configuring the pools is our sources helper. And so with our sources helper, similar concept. You're going to have a TOML file or a JSON file, and it's going to have the various sources that you're able to send messages through. So for example, you might have 3 IPs that belong to a pool. So we're setting up here IP1, IP2, IP3. We're putting in our eHello host name, the source IP address for that. That's all we need in a basic configuration. And then beyond that, we set up our pools. You cannot assign tenants directly to sources. They have to be assigned to pools. So at the very least, your tenant or your pool is going to have one source in it, and then that pool can be assigned to a tenant or to multiple tenants if you're using it as a shared pool. So then we say, okay, here's the name of our pool, and here's the elements that are incorporated into it. And what you'll notice here is we have a wait element. So you're able to do weighted round robin by using arbitrary numbers that you want to set up in the weighting category, in the weight value, and that weight then is used as part of a weighted round robin. If you do not assign weight to members of a pool, then it's equal distribution. Other than that, the ratios are calculated. So if you set 2 and 1, for example, here, so that weight 2 on IP2, weight 1 on IP3, we're going to use IP2 twice as often as we're going to use IP3, right? At 2 messages to 2, 1 message to 3. This can be set to any arbitrary numerical value. So if you want to put it to, for example, numbers out of 100, then you're going to essentially be doing effectively percentage weighting, right? So if you say 60 and 40, then 60%, 40%. So it's going to use that not to actually literally do it as a rotation, it's calculating the ratio out of the numbers that are part of those members of the pool, part of the weight. And from there, go back to your tenant helper, set the pool names for the tenants as you see fit, and now your tenants are assigned IPs in pools. Last one I'll show you for now is our listener domains helper. The listener domain helper is there to configure inbound domains. So you have your listeners set up in your configuration for which ports you're listening on, which IPs you're listening on, but we need to know how to handle traffic that comes in. So if we see that someone's on the relay hosts, then we're allowing them to relay messages out regardless. If they authenticate, they're allowed to relay messages out. But messages are also coming in from the outside world because you have this set up as your MX record, maybe for your bounces, so on your return path domain, maybe for feedback loops, so that you've set up a domain that those are specifically sent to. Maybe this is actually part of your corporate mail environment, and you're actually accepting arbitrary mail in because if it's destined to your company domain, you want to be able to pass it on to your IMAP server, for example. So all of those scenarios are available. And what you do here is you create entries that say, all right, what are we doing by default? And by default, maybe we're saying, hey, any domain we listen to, any message that comes in, we're not going to allow it to relay in and just be delivered to an IMAP server, for example, but we will identify whether the message coming in is an out-of-band bounce or if it's an ARF formatted feedback loop message. And if it is, then we're going to accept those messages. We're going to parse them using the out-of-band bounce parser and again, the feedback loop parser, and then we're going to drop those messages. So that's our default. And then we say, well, you know what? We've got example.com as a domain. That is a corporate mail. So we are going to say relay2 equals true. So now we don't accept mail in for relay unless it's a bounce or an FBL or it's destined to example.com. Right? And if our defaults were all false, for example, then maybe we want to go here and say, okay, bounce.example.com, we're going to log out of band on it, and fbl.example.com, we're going to log as an ARF, and maybe, for send.example.com, we're saying, look, as long as the sender domain is send.example.com and the peer coming in is 10.00.24, then we're going to allow that relay out to occur. The difference between this and, for example, just relay hosts is here we're being selective, right? With relay hosts, we're just saying, look, if you're in the list of relay hosts, then you're allowed to relay mail. Here we're saying, rather than setting up a widespread relay host rule, we're instead going to say, if you're from this IP and you're sending from this domain, then you're allowed to relay on our behalf. And then below that, of course, you can see an example where we're doing it again based on OTC. So here we're saying you can send from that domain as long as you're one of these two users, which is different than what we're doing with tenant. You could combine the two to be really strict and say, as long as they're coming from this domain and they're authenticated, then they can use this tenant to send from this domain. So you have full control there by setting these up. That's our helpers in a nutshell. Hopefully that helps you to ease your configuration and make it more simple for you to use not only your own policies, but if you're starting with our example server policy that you can find on this page, it's built now entirely out of using policy helpers. Here's all the references to the helpers, and then down below, that's where they're instantiated, and down below you'll see that every section you encounter where you have to set up things like setting up a listener domain, setting up shaping, all of those now are done by leveraging the helpers. Let us know if you have any questions. Feel free to join us on our Discord, KumoMTA.com/Discord. Ask us in the forums, forum.kumomta.com. Always happy to help you out. Thank you for watching.